Hello, everyone, and welcome to the CNC Meetup, August 2020. It has been quite a long time. The last one was in February, we just discussed before. So I think it's really time again to have a meetup like this. My name is Marcus. I'm from Vision. I will quickly go through the agenda today. Let me share my screen. And honestly, I can't believe I'm using Safari for this, but yeah. So first of all, Adrian, my colleague, will give a quick recap on the KubeCon 2020. He joined a couple of talks there and watched some of the live streaming sessions, and he will quickly give a recap on how his experience was. And maybe you can later join for a discussion for this as well. And also new updates on our Project Syn. And after that, Simon from Red Hat will talk about operators and operator framework. Afterwards, Jürgen from Dynatrace, overcoming scalability issues in your Prometheus ecosystem. And finally, Roman from Swisscom will talk about cloud-native Buildpacks to unite PaaS and CaaS. And around 5, I would say we should be done. So unfortunately, no beers remotely. I mean, of course, we can stay in a Zoom and have remote beers, but I guess most of you guys already had enough in the last half year. So I don't know. We'll see how it goes. And one more thing. Look at this. We started the Swiss Cloud Native Alliance. Yeah, what is this? Like we found out like there's so many different little meetup groups and cloud native initiatives and stuff going on in small little Switzerland. And we thought, why are we all doing the same? Why don't we join forces and combine these forces? So we basically said, okay, let's start easy and with a small scale website where we at least have the different meetup groups which are currently available in Switzerland, and also like to have one event calendar for all the different meetups and stuff. If this works, it does, okay. And just to make it easier, because I think that was this summer somewhere when we actually planned a cloud native meetup in Bern and Zurich in the same week. That just doesn't make any sense. So I hope this will help for the future to combine Swiss cloud native forces and also to, yeah, maybe create a better experience for potential customers or people who are interested in the cloud native topic and who are looking for help. So yeah, I think that's it. Then I will hand over to Adrian.
Great. Thanks, Marcus. Hello, everyone. Thanks for joining us in this Cloud Native Meetup, the first completely virtual one. So let's see how this all works out. I think so far we're pretty well. Thanks a lot for joining. And let's start by, the usual sharing my screen. So I'm going to select one screen to share. There we are. And I'm going to change so that I can see my slides. Very good. So here we are. My name is Adrian Kosmaczewski. I'm developer relations at Vision, and I'm going to talk about 2 things today. Very quick introduction talk. First of all, some news from KubeCon and Cloud Native. I don't know, maybe some of you have also participated to the event. So let's chat and talk about impressions during the event. And of course, we're gonna have a Project Syn update and the first ever live demo of Project Syn. You're gonna see Project Syn in action, and I think this is cool. We are reaching the point where we can actually start showing things that actually work, and it's super, super, super cool. I'm super excited to show you what we're doing at Vision. So first of all, some news from KubeCon. So maybe some of you have joined some of the videos to watch. I think many of the the myriad of different things that were said and done during the event. Maybe one thing that struck very strongly in me was the fact that we are 6.5 million cloud native developers, and the growth is 2 million per year. So this is clearly a very strong growing segment of the industry. And this was announced during the keynote. And it's actually quite cool to see that we are so many and we are growing every day. Another very important announcement was by Red Hat announcing new versions and updates for all of their developer tools. They've got a huge array of incredible tools to use. I'm a big user of code-ready containers. I'm not running it right now in my computer, but I usually have one instance of it running. So it's really exciting to see all of the new tools that are coming up. Also, by Red Hat, the possibility of running OpenShift on the edge, which opens the door to Internet of Things, the installations, and it really opens up to new capabilities and new ideas for using OpenShift. So it's really, really cool to see Red Hat moving in this direction. And something that we are very excited about is about Argo CD, because Red Hat will collaborate with Intuit in the development of Argo CD. And today, you're going to see Argo CD in action. So this is actually very interesting for us. We are using Argo CD as one of the components of Project Syn. So we are extremely, extremely happy to see that this collaboration is growing and that the product is getting so much help from a big company like Red Hat. If you want to know more about what's going on, I found 2 interesting articles, one from Forbes, of all places. I wouldn't have thought Forbes, a business magazine, taking care of what's going on in KubeCon. Clearly, there's a lot of business going on in the cloud these days. And as well in Toolbox. And having said that, let's go to the interesting stuff, which is the Project Syn update. So some of you don't know exactly what is Project Syn, so let us do a small introduction to begin with. Project Syn is a tool developed by Vision, open source, 100% open source, available on GitHub, that allows us, and we're already using it, to manage lots of clusters. And when we say lots of clusters, we're talking in the hundreds. There's a lot of work that we have to do that we want to make automatic, that we want to script. We want to have the possibility of defining the configuration of a lot of clusters at the same time. And this was a huge lot of work for those of you who have to maintain clusters. You know what I'm talking about. It can be really complicated. So Project Syn helps us a lot to get a lot of work done in an automatic, configurable way and repeatable way as well. Project Syn has many interesting features. First of all, it allows you to have multi-tenancy and multi-cluster management. You can have full GitHub observations. That means that when you change the configuration of a website on your Git repo and you push it, automatically a synthesized cluster, that is a cluster that has Project Syn installed, will automatically pick up those changes and apply them without you having to do anything. And we're going to see that right now in the demo. There's configuration management integrated, reusable components. We're going to use one very simple component that I've developed for this, this presentation that basically just shows a funny quote on your cluster. And we've got automatically maintained components, automatically updated as you work on them. Secret management built in, this is very important, and service provisioning of any kind of service inside of any synthesized cluster. So clearly there's a lot going on. And when you look at the architecture diagram, you're like one step back because there's a lot going on. But the interesting parts that you should take care of, I don't know if you see my mouse, I hope so. Basically there's on the top left side of your diagram, there's the Lieutenant API. The Lieutenant API is the one-stop connection point for talking to this multi-cluster installation that belongs to a tenant. And inside of each Kubernetes enabled, Project Syn enabled Kubernetes cluster, we've got what we call Steward. And Steward is running, managing Argo CD. Argo CD is keeping an eye on the repositories that contain the configuration of your clusters and automatically applies the changes as they happen. We have another very important component, which is Commodore. And Commodore can be extended. We have a lot of different components. We can perform lots of different tasks with Commodore components, and the API is open and you can create your own components, and we welcome very much people who are already contributing components on GitHub. So it's really, really cool. It's generating a lot of buzz. So the important news about Project Syn is that we've just released the second beta. So this is a work in progress. There are many things that we still have to work on, but the team is doing an amazing job working at full throttle and adding new features. So speaking about new features, right now we've simplified the calls to Lieutenant to get cluster synthesized. Remember, synthesized in this context means that the Syn tools are installed in the cluster. There's the automatic cluster decommission, because that happens as well. Sometimes you have short-lived clusters that you might want to take down, and there's a lot of cleanup to be performed. And we have a cookie cutter template for components. This is great because it can get you started very quickly to create a new component out of the blue. And lots of new documentation. It's something we've been working a lot. We've got the website docs.syn.tools. We're going to see that in a minute. It contains a whole lot of information about how Project Syn works. And of course, we are preparing the roadmap for version 1.0. There's a lot of work that we still have to do. In particular, more documentation. We need to document more everything that we do. So this is one of the key goals. We have to improve the developer experience. Some things are still a bit complicated and require insider knowledge. We are going to tackle these issues as we move forward, because we want to have people to use Project Syn in their own clusters as much as possible. We are going to automate as much as we can, particularly cluster provisioning and bootstrapping of clusters. This is something that we need to do a lot for our customers, and we actually want to have this feature built in. If you're interested in knowing what the roadmap looks like, you've got this website, syn.tools, that contains all the information, including the roadmap, but there's a whole lot of information there, including the design documents, where you can see all the discussion that happened around a particular feature of Project Syn. We are keeping this, all of it in the open, with an open management of these features, and you can see how they are designed and why they are the way they are. So we welcome everybody to check them out. However, enough said, it's actually much more interesting to show you what we are going to see today. And I'm super excited. I'm stoked to show you this. I'm going to show you a very simple, very simple use case, of Project Syn. I've created on my machine right now, which is the fans are spinning because, of course, between Zoom and the clusters, you can imagine I'm consuming quite a bit of CPU time. And I've got Minikube, K3D, and Kind, who are three small versions, small installations of Kubernetes, where we have synthesized, we have applied all of the Syn tools into them so that we can play with these three clusters. And this is running, everything is running local. So demo time. So let's pray the demo gods and hope that everything works, right? Let's see right now. I'm going to change to my terminal. I hope everybody sees the terminal. You can nod if you see. There you go. You see. And this is what I have right now. This is live on my laptop, and I see there's a Minikube on the left. On the center, I have K3D and Kind on the right. This tool that I'm using is K9S. If you do anything with Kubernetes, you have to have it. This thing is an absolute lifesaver. It's an absolutely fantastic tool. It makes it really easy to work on the command line with Kubernetes clusters. So it's really, really cool. And as you can see, the three clusters contain the Syn tools. In the Syn namespace, as you might expect, they are highlighted in each one of these screens. And you can see as well on Minikube, on the left side in Minikube, I have the Lieutenant namespace because I'm using Minikube as the support for the Lieutenant API. Remember, the Lieutenant API is what I showed in the previous slide with the diagram. The Lieutenant API is the one-stop API where you interact with all of your clusters all together, all of the clusters that belong to a tenant in one single place. So I'm using Minikube for Lieutenant, and I've synthesized the 3 clusters altogether. And what you see on the lower part of the screen, and I'm going to zoom out a little bit just to show, I'm basically looping, I'm basically, how do you call this? Watching, there we go, that's the word I was looking for. I'm watching the curl localhost 9090 command, okay? Of course, right now I'm not exposing any network service on any of my clusters, but I'm exposing the 9090 port on this one, the 9091 on this one, and the 9092 on this one. And as soon as I have made my deployment, I'm going to share, I'm going to create port forwards directly on K9S so that I can interact with this deployments. So how do we deploy something? So here you see the output of the kubectl lieutenant get tenants and get clusters command. So you can see that I have 1 tenant, and I can see I have 3 clusters attached to that tenant, which are the kind cluster, the minikube cluster, and K3s cluster. How these things work? Well, basically there's a GitLab repository for each one of the pieces of this installation. This is my GitLab account. I have 3 private projects that have been created by Project Syn, which are the tutorial cluster kind, cluster K3s, cluster minikube, and cluster tenant. Each one of these projects contain information regarding the configuration of all the pieces that make up this cluster. And of course, the tenant itself contains information about the 3 clusters that are contained therein that belong to it. As you can see, the names are exactly the same: Dawn Leaf, Small Fire, Summer Noon, Dawn Leaves, Small Fire, Summer Noon, right? So these names are automatically generated when you synthesize a cluster in Project Syn. So this is really cool. Right now, what I'm gonna do as well is to show you Argo CD. I have Argo CD is right now running, and this is Argo CD running on Minikube. This is my Minikube instance. I have exposed, I have made a port forward on port 8080 so that I can see Argo CD running. So Argo CD is running and watching for configuration changes. And this is managed itself, it's managed by Steward, which is the Project Syn component that manages Argo CD. Very good. So now what we're going to do is to do something fun. We are going to actually change the configuration of our cluster, and I hope the demo gods will help me. So the only thing I have to do right now is to, first of all, I wanted to show you what the commands look like, because to create components and to interact with components, you have to use the Commodore command. And the Commodore command, instead of installing the whole command, Commodore command, which is based in Python, I'm using the Docker image. So I'm using a Docker image. I'm running the Project Syn / Commodore version 0.2, which is the latest release at this time. And of course, I'm also using another command, which basically loops over all of the clusters of my tenant. And for each one of these clusters, I'm going to compile a catalog. This is a little bit there's a little bit of knowledge. What is a catalog and all of that? No worries about that. We have plenty of documentation. I'm going to show you in a bit where to find it. But let's assume for the moment that when you work with catalogs, when you work with components in Commodore, in Project Syn, you need a catalog, and that's okay. So let's modify that catalog. So I'm going to cd into inventory classes tBlueBrook. So as you can see, tBlueBrook is the name of my tenant. So here I have the configuration of all my tenant, and I'm going to change the configuration of the common.yml file. The common.yml file, as you can imagine, there's a YML file for each one of the clusters. You can see that on the left side of the screen. But I want to apply something to all of the clusters at once. And what I want to do is to add a new component to my to all of my clusters in one shot. And for that, my component, it's called Fortune. And basically what I'm doing here is to specify in the configuration of my tenant that I want all of my clusters to have that component. What is that component? We're going to see it in a minute. It's basically a Kubernetes deployment that deploys a very little application written in Python. Nothing else, nothing more than that. So let's save this. Let's commit -r-m added component. There we go. And I'm going to push this configuration. Very good. So now I can go back up and I can launch the compilation of all of the clusters. And for that, I have this Commodore compile all command that I just shown you. And this thing basically runs the compilation and the pushing of the catalog for all of the clusters that are attached to my tenant. So this is very easy. Actually, you can try and write the comments yourself. I'm very lazy, so I prefer to do it just in one shot and I get everything done. I have to enter the passphrase for each one of the runs of this thing. Why? Because basically I am using a Docker container and the Docker container it's being stopped all the time. I cannot have a daemon running with my credentials. So I have to re-enter my credentials every time. But the interesting thing is the green text that you see there. We've added 4 things. One of them, it's a manifest, an application called Fortune, and we have for the manifest for the Fortune app, we have a deployment, a namespace, and a service. And that is literally Kubernetes YAML, like you've seen 1,000 times in plenty of other deployments. So I'm going to do the same for the second cluster, which is C small fire in this case. So it's going, it's configuring, it basically does exactly the same thing as it did previously. And I'm going to do the same on the third one, which is right here. It pushes everything to remote, there we go. And I launch the third one and I jump to the tab where I have K9S running. So this is going to take a little bit of time, probably 1 or 2 minutes. And you're going to see that basically there's a new namespace that appears. This is why I'm showing the namespaces tab in K9S, because there's a new namespace created. It's called Syn Fortune, just as a way of wrapping my own deployment into a namespace. And this namespace will appear in each one of the deployments as we move on. So take a look at it right now, because right now we don't see the deployment or the namespace. It's going to be there in a few minutes. Another thing that I want to show is in Argo CD. This is running right now in my Minikube, and in my Minikube, of course, this thing will, in a couple of minutes, show a new box right here in this screen. There will be a new box called Fortune that will basically contain all the information required to install this deployment into my Kubernetes cluster. So there we go. We have one happy Syn Fortune namespace. So the first one that got it, it's a little bit random. Sometimes K3D picks it up faster, sometimes kind, sometimes Minikube. In this case, it was kind. So it was very kind of you to pick up this new namespace. And if I go into the namespace, I can see a deployment with 2 pods, which is exactly the configuration that I had defined on my component. And this is very, very nice. As you can see, it's happening as well in K3D. K3D is picking up right now the Syn Fortune, and I'm going to create a port forward from to the local port 1992, which is the one that I want right here. There we go. And as I do the port forward, in the lower corner, you can see that I can now talk to my deployment. I will do the same on this side. I will select the Syn Fortune namespace. I can see my deployments with 2 pods. This is exactly what I wanted in the description. I go to Shift F right now. I'm going to expose port 1991 right here. This guy will start to talk as well because curl was basically watching and running, and I can do the same here on Syn Fortune. I will create a port forward to 9090, and that's okay. And I have all of my deployments, my 3 clusters updated automatically just because I changed the configuration of my tenant on my Git repositories. And that was everything done via Git. That's why Project Syn is so heavily based in GitOps. And we actually use the GitOps paradigm as much as we can with this project. So there you go. You've got a very nice introduction. This guy I will just refresh the page right here because sometimes this web page takes a while to refresh itself. So there we go. Argo CD has here a new box, as I explained previously, for the Fortune component. If I click on it, I can see the structure of my deployment, and the synchronization happened 2 minutes ago. Of course, we already know that because we've already talked to the Fortune deployment. And the Fortune deployment, what it does is basically to show you the Fortune cookie of the day. That's everything it does. There's nothing else. Very good. So I'm very happy because the gods of the demo were with me today. Thank you so much. And that was really, really cool. If you want to know more, because of course there's a lot going on behind the scenes, we just published a great first Commodore component tutorial, and it's available on Doc Syn Tools right now. And you can basically go through it. There's a lot of information about how to set up the tools, how do they work together, why you should write a certain number of commands. Of course, what I've shown is just a little bit of an ice cube on top of the tip of the iceberg. It's nothing at all. But I wanted to show you this because this is the true power of Project Syn. It's basically being able to automatically configure lots of clusters with the same configuration, the same parameters in a predictable way. And this is really powerful. So I will publish these slides. We will make them available anyway on the Meetup groups for you to download. I have all the links of all the things I've shown today, the articles about cool new things in KubeCon, as well as the URL of the Syn Tools tutorial, which is in docs syntools/tuto/index.html. So go check it out. Play with the tools. And of course, if you have any questions, if you have any doubts, if you would like to use Project Syn in your own deployments and you think it could be useful for you, just contact me. My email is adrian@vision.ch. I will be super happy to guide you and to help you. And the team thanks you already for using Project Syn. So thank you so much.
Awesome. Thanks, Adrian. I think that was a good introduction. And I was just noticed that somebody asked, like, who were the founders of our Swiss Cloud Native Alliance story. So let me quickly share that again with you. So it's basically camp to camp, kind of taking care of the Romandy part, puzzle, taking care of Bern, and of course lots of other Swiss German parts, and we as Vision. So we three companies started this whole initiative, and yeah, I mean, let's see what the future brings, and we are happy for your feedback, and if you want to get involved, let us know. Thanks. So let's continue with Simon, if I'm not mistaken.
Sure. Yes, so let's go ahead.
Hi again, and thanks in advance for your talk.
Well, you shouldn't thank me yet. So there you go. You should see only the presentation. Is that correct?
Yes, perfect.
Wonderful. All right. Okay, great. So thank you for joining us today for this presentation on operators and the operator framework. My name is Simon Krenger. I'm a technical account manager at Red Hat in Bern. And yeah, so let's get started. So today we'll have a look at what is an operator, what the operator framework is, the components of this operator framework, the operator lifecycle manager, operator hub. And if everything goes well, we'll have 3 short demos, and I hope they go as planned as well. So let's dive right into it. So what is an operator? So operators have been a bit of a hype. Apart from service mesh being everywhere, there are operators everywhere nowadays. So it turns out that nowadays deploying things to Kubernetes is quite straightforward. We have things like Helm charts, which are a good way to deploy even complex applications. We have tools like Argo CD that we just saw that help us to closely control what is deployed. and we have stuff like customized to template YAML files to our clusters. So far so good. The issue is that it's typically not done by just deploying the application in Kubernetes. What about day 2 tasks? Application lifecycle, updates, backups, resizing, recovery, monitoring, scaling, all these things. So these tasks are typically harder to solve, and this is what operators are all about. So here is the marketing slide about it. An operator is a site reliability engineer implemented in software in a Kubernetes native way. Well, that sounds pretty nice, but okay. So the idea of an operator is to have your application knowledge and day 2 knowledge embedded in software. So the idea is not only to encode how to deploy something, but also how to run the thing. So when we look at what an operator does, it is a piece of software that knows how to do certain application-specific things in Kubernetes. So instead of treating an application as a collection of primitives, such as pods, deployments, services, config maps, what have you, we treat the application as a single object. And to do this, we extend the Kubernetes API and use custom resources and also other patterns of Kubernetes. So we extend Kubernetes with custom resources, and then, as I said, we use these Kubernetes principles such as the control loop to check if the desired state matches the observed state. So an operator runs the control loop over and over again and checks, hey, does the desired state match what I want to have? So it then takes steps to reconcile any differences it observes. So basically, an operator is a Kubernetes controller for our own application. So more specifically, so you have an operator that runs this reconciliation loop over and over and over again, and it watches the API. It watches the Kubernetes API. And watches this for changes. And this operator itself is a standard Kubernetes deployment with a pod that's running the operator code. Now, when the user creates or modifies a new custom resource for our application, the operator will notice that and will go ahead and create the pods and other primitives necessary to run this application. So to summarize, an operator is a pod that will watch the Kubernetes API, will react on certain custom resources, and then will take action to create or modify or whatever needs to be done. So on the other hand, this also means that if you do manual changes to these primitives, so if you change a deployment or whatever, the operator will make sure to revert that change, because all it does, it watches the custom resource and it applies the desired state of the custom resource to your cluster. So fun fact, my first contact with an operator was pretty negative because I manually changed a deployment and it was changed right back. And I didn't quite understand why this was happening, but it turns out that this deployment was controlled by an operator. So there we go. So let's have a look at a specific example for this. One thing that always comes up is this the Kafka application. Kafka is an event streaming application that can become quite complex. There are multiple parts to it. That's not exactly it's not exactly important to understand what exactly Kafka does or how it works. It's important to understand that there are multiple components to it. So what we can see here is a custom resource of kind Kafka. And we see that the fields that we have in this resource, this is all very much application specific. So there's things about listeners, there is storage, there are replicas. This is something we know from Kubernetes, right? But it might have another meaning in Kafka. So it's very application specific. And then let's see, so we have an operator for Kafka, for example. We will see it in the demo later on as well. So we have an operator for Kafka, and whenever the operator sees that there is a new object of kind Kafka, it will take action. and it will create pods, stateful sets, services, config maps, whatever needs to be done in order to have a Kafka cluster. And here we see, for example, that Kafka has 3 replicas, and then on the right we can see, it creates 3 different pods for this. So we can see that an operator translates from very application-specific object to the Kubernetes primitives. So let's have a look at this in a short demo. Here we are. So in my cluster, I have the Strimzy Kafka operator running. So the operator is running, it's watching my API, and when I check what this operator provides, I can see that there are lots and lots of custom objects that this operator operates on. So we can see that this is not only about pods and stuff, it is also about very application-specific things, such as users or topics. So not only Kubernetes stuff, but also application-specific things. So let's have a look again at this object that we're going to create. So again, we have a custom resource that's called kind Kafka. It's the same that we saw in the presentation before. It has 3 Kafka replicas, 1 zookeeper. So, and if we apply this, let's see what happens. So we apply this YAML file to our cluster. And so what the operator will do, it will see that, hey, there is a new Kafka object being created, and then it will go ahead and go and start these pods. So here we can see there is a zookeeper pod already being started. It's not yet ready, but I hope it will be any minute. And then we can see that the operator will create all the other resources that are necessary to run this Kafka application or this Kafka cluster in this case. So that seems to work nicely. It's now initializing, starting up, not becoming ready yet, but we'll get there eventually. So by applying a custom resource, I was able to start a whole lot of things. There are now pods and lots of other things happening. So of course, I can have a look at this one and go here. And now is for the interesting part. I can, of course, edit this object and, for example, add more zookeeper pods. And now is the amazing thing is I don't need to know what needs to be done in order to add another zookeeper to my cluster. I guess there are multiple steps necessary to do so. I don't exactly know, but I don't care because the operator abstracts this away from me. I can just increase the number of replicas, and hopefully we'll see that there are now more zookeeper pods being started. So as the last part, I already noted that the operator does not only do Kubernetes things, it also interacts with the application directly. So here we have a Kafka topic. A topic is something that is happening within Kafka and is very application specific. And the operator also manages this for me. So it will check if in this cluster this topic exists, and if it doesn't, it will create this for me. So I have a Kubernetes native interface to my Kafka cluster. That worked nicely. So back to the presentation. So now we've seen what operators are. It's a pod that routes the API and does things on Kubernetes. So there are multiple patterns on how operators work. So one pattern is that it creates in-cluster resources. This is what we just saw with Kafka. Another pattern is to manage external resources with an operator. So you have a Kubernetes native interface to resources that are external of your cluster. For example, firewalls or databases or whatever you have. So you can not only use operators to do in-cluster stuff, but also to talk to stuff outside of your cluster. So there are different things that an operator can do. We can see here that the most basic thing that an operator can do is just deploy things. That's the easiest part. And it can update things. but we can also do that with Helm. And actually there is, in the SDK that we will see later on, you can convert Helm charts to operators and have your Helm charts as custom resources, and the operator will create objects for you. When we implement more advanced operators, we're adding additional features, such as being able to create backups or having application-specific things within the operator, or even better, having metrics exposed and have the operator automatically scale my application. And the end goal for an operator should be to have a kind of autopilot that automatically scales your application and fixes your application if there are problems that can be seen in the log. So that will be the best thing ever, but we're not there yet. So some practical tips to interact with operators, especially when it comes to having lots of custom resources. So there can be lots and lots of resources being managed by an operator, and kubectl API resources can help you to list these custom resources, and then you can use kubectl explain on a certain custom resource, so you can see what fields there are. And the explain command will also give you a very nice overview of the documentation of that field. Then operators typically update the status of the CRDs very well. So there are multiple fields that you can pay attention to. And if you know that there is an operator around somewhere on the cluster, you can check if a certain object is managed by an operator by using the managed by label that is typically applied by an operator. Okay, so we have seen what operators do, how we can interact with them. Let's see what we can do with the operator framework and what that's all about. So the operator framework is a CNCF incubated project, and it's a toolkit to manage operators in an effective, automated, and scalable way. So it includes SDKs for Go, Ansible, and Helm charts. It contains the operator lifecycle manager, which we will have a very brief look at later on. It contains the operator registry, and there are lots of community operators that are already available and that we can already use. So the operator SDK is a great way to write your own operator. So basically what you're going to do is use the SDK. It's a command line application. We'll see it in the demo to create all the scaffolding that's necessary. So you don't want to spend too much time to dig around creating all these CRDs by hand, etc., etc. There are generators for these kind of things. And also we will see that installing an operator involves a few components. So generating these using an SDK is a nice way to do that. So as I said, there are 3 ways to create your own operator using the operator SDK. You can convert a Helm chart to a Helm operator, which can install and update stuff. Then you have the possibility to have Ansible playbooks being used by the operator. This is what we'll have a look at in the demo. And if you need full control over everything, then there is always the possibility to go full native with the Go SDK. So depending on what you want to do or what you want to interact with or what you already have, there are multiple ways to go about. So let's have a closer look at this Ansible operator thing. So instead of having code that is running in this reconcile loop, there is a small part of code that does run as Go code, and then we can use Ansible roles to apply changes to our infrastructure, for example. So this is a great way, for example, to work with external resources, but we'll have a look at in the demo real quick. There we go. So let's have a look at the demo for the SDK. So first of all, before I do anything, I'll go ahead and create a new folder for my operator. And I'm using the operator SDK CLI to bootstrap everything. So first of all, I'm going to say, hey, I want to create a Ansible operator. And then I'm going to go ahead and create my custom resource. In this example, we're going to do a custom resource of kind presentation. So I'm using the operator SDK to create all this scaffolding. Now, when we have a look at what is generated, we can see that there is tons of things that are being generated. There is are the CRDs that are being generated. There are the role-based access control bindings and everything. There are some samples. There are and back down here we have an Ansible role that is being executed for each of these CRDs. So let's copy the example here and have a look at that. So in this case, I have a custom resource that's called presentation. It has one field. It's called foo. And then what I want to do is for each of these custom resources that I create, I want to create a new deployment with a simple pause container and then have an environment variable where I use this variable. Very, very trivial. So let's go with that. And as you have seen, this is written in YAML. It's an Ansible role, and you can use any module of Ansible that you would like. So by using the SDK and the files that were generated for me, I can do a Docker build. And yeah, it will do that for me. So it will build the operator from the Ansible playbooks that I created. And it will push that to quay.io, I hope. So let's see if that actually works. I see that Zoom is taking quite a bit of resources here on the laptop. The fans are ramping up. But it looks like we're getting along well. Oh, there we go. Nice. So it seems that we built the operator and we pushed it to quay.io. Very nice. So next up, let's go ahead and install the CRD that we just initialized before to our cluster. Basically, going to install, use customize, and apply that to my cluster. And we can see that the custom resource definition has been created. And now let's deploy the operator that we built in the steps above. So as you can see, this applies all the necessary role-based access control roles and bindings, etc. And also creates a service and whatever is necessary. Quite nice. So when I have a look at this operator, I can see, oh, it's running. That's very nice. So if we apply this sample, I create this custom resource, very nice. So I can now do a kubectl get presentation because that's the name of my CRD. And I see, oh, it's there. That's good. So when I have a look at the definition of it, it's a very, very simple custom resource, right? There's a spec with one variable that's called foo, and then the value is bar. And this theoretically, what I can see now is when I check the operator should have seen, hey, there is a new custom resource. Let's create a deployment. And when we have a look at this what the operator does, we can see, oh, this looks very much like Ansible. And we can see that it applied all these roles that we wrote before. And yeah, there seems to be something that has changed. So that seems to have worked. Let's see what there is. And indeed, so it's a bit not so nice, the output here anyway. But what we can see is that there is a new pod that is running. It has a container with an environment variable with the value bar that we had in our custom resource. Very nice. So that's the Ansible operator. So you can use Ansible roles to create your own operators, which is very nice. So the next thing I want to talk about is the operator lifecycle manager. To be honest, it's not very interesting to me, so I will keep it brief. The operator lifecycle manager is basically the package manager for operators. So we saw before that when we build an operator, there are lots of resources that we need. We need to build the operator itself, the container image. We'll need to have the deployment for that operator. We'll need to have the bindings and everything. So this gives us this bundle. And we can use the operator lifecycle manager, which is a CNCF project, to manage these operators on our cluster. And what that means is we can subscribe to a certain package, and we can install, manage, and upgrade operators and their dependencies. So as I said, you bundle your operators into this bundle. The SDK helps you here as well. And then the lifecycle manager deploys this operator. It can also do the upgrade for you. This is something, if you have worked with customers, updating these can be a challenge, but the OLM can certainly help you here. So let's have a quick look at this one as well in this demo. So if we go over here, in my cluster, the operator lifecycle manager is running, and if I have a look at it, it's yet another pod that's running, and it's also watching certain custom resources. So for example, in this cluster here, I have installed the Strimzy Kafka operator that we have used before. And if I query it, yeah, we can see, oh, it's on the stable channel and everything. So here we see that the OLM is managing this operator for us. Now, this is all very nice. You can all do everything via the command line, of course, because it's all custom resources. There is also a GUI, which you have a look at here, and you can basically go into any operator, see what kinds of custom resources it provides, can have an overview of how this, if this operator is updated automatically, for example, or if you want to do it manually, or what kind of channel you want to use. Do you want to use the development version, etc., etc. Something that the operator lifecycle managers can also be connected to, doesn't have to, can be, is the operator hub. The operator hub is basically a marketplace where there can be community operators, and then as you can see, there are already lots and lots of operators available. And as we will see later, there are around 150 operators that can be used and are there by the community. Some are by vendors, other are open source projects. So, and you can also, for example, let's have a look at AMQ Broker here. And yeah, just click the button and it will install the operator for you. So on operatorhub.io, some of the more popular operators are this Kafka operator that I showed the demo before, Prometheus, Istio, Crunchy, the PostgreSQL operator. So there are lots and lots of community operators that you can use that are already available. So let's have a look at the best practices and some example of operators. So ideal use case for operators are stateful applications. This is why we've seen PostgreSQL before, clustered or highly available applications, and of course microservices where you have lots and lots of dependencies. An operator might be a bit of overkill for stateless applications and is not well fitted for any infrastructure or host agent kind of thing. So when we have a look at the real world, so what are people actually using? So what I have seen before is that people are using the Crunchy DB Postgre operator for databases in development environments. It's a very nice, very nicely abstracted way to deploy databases for a development environment, for example, or automating your CI/CD pipeline using Ansible Operator. And something I've already said before, you can also use it to provision and configure external resources to make these external resources Kubernetes native. On a side note, OpenShift, which is the Kubernetes distribution from Red Hat, uses operators very extensively as well. There are about 25 cluster operators that are installed by default. And so we're using this concept as well in our own products. A few best practices. These slides will be made available to you after this session. For the development of operators, so we have basically have one operator per application. Use an SDK like the operator SDK, and don't write it from scratch. It's not a fun thing to do. And for running operators, it's always helpful to have this status information. And the operators are typically configured using configuration custom resource. So whenever there is an operator, there is typically somewhere a custom resource that you can use to configure how this operator behaves. And this can help you running these operators. And with that, that's everything from my side. If you have any questions, please add them to the Zoom Q&A, I think, and I will be happy to answer all the questions for you. Thank you very much.
Thank you very much, Simon. Awesome talk. Yes, I would say just shoot your questions whenever you have them in the Q&A, and we try to answer them as soon as possible instead of waiting for them to the end. Yeah, I would say then let's continue with Jürgen.
Okay, thank you. Let me share my screen. Also, let me know if it doesn't work, but you should be able to see my screen.
It works perfectly.
Okay, cool. So let me get this started here. So yeah, also thanks for having me here at your great meetup. I already enjoyed the first two talks, and it's very interesting to see that we have some kind of connections. We are also using Argo CD in this project, Dynatrace itself. We also have an operator, so it's great to see that the whole ecosystem somehow is always kind of connected. And yeah, for today, I want to talk a little bit. Yeah, thanks, Adrian. For today, I want to talk a little bit about like what I discovered, or like my personal learnings, and also what when we worked with customers or prospects that were using Prometheus, which challenges they faced and how they could overcome those challenges. Yeah, I just want to talk about this briefly. So yeah, I work at Dynatrace. My name is Jürgen Etzlstorfer. I'm a DevOps activist. I care about the ecosystem for our own open source project that's called Captain. I already put a lot of links here, but we will only see Captain as in the second part of the presentation, because it's like this talk shouldn't be about a tool, but more about like what are the challenges, how you can overcome them. And then I will show like one potential solution, how you can do it if you want to use open source software. But I will also give some hints how you can do it without using this kind of tool. So all the links, I think, for the beginning are here. So let's dive right in. So what we have seen is what yeah, customers, or what people that work with Prometheus or work in Kubernetes, what they actually want is to have observability, visibility in their clusters. They know they need to know what's really going on in their clusters. And Prometheus is a very prominent example for a monitoring solution. So they have Prometheus, they have their alerts, they have their dashboards with Grafana most often. That's what we see. And it's important that like everything is set up in an automated way. They don't want to spend a lot of time on like setting the whole thing up, because they make money with their applications running on top of Kubernetes, and most often not on managing the Kubernetes cluster. So I think that's also already great what we've seen with Project Syn. I think that can take a lot of effort away in managing the clusters. Or when you have operators, I think it's also a great way to manage your applications, and not like you have to deal with all the details of applications, but you use a lot of automation. And that's what we also see. People want to use a lot of automation also in this ecosystem. So I want to start like a little bit, what are the basic building blocks that I will tackle in this presentation. I will address 3 different challenges. They are basically building upon each other. That's what, like, this is how we could structure them a little bit when we were working with customers. And then I will present at the end the open source project Captain that I'm also heavily involved with. And I've also written a blog on this. So a lot of parts that I will talk about today, they're also written in this blog. I put the link here. I know on Medium, they have this paywall, but it should be in front of the paywall, and I've made it a friends link. So with this link, you can always access it, regardless if you already used your free tier or not. So that should be fine. So when we talk about observability and monitoring in Prometheus, we basically have our cluster. We have also our Prometheus inside the cluster. We might have even more instances of it, but most obviously, most often, we have more instances of application clusters. And each pod, they expose the metric, and Prometheus collects all the metrics. And then either folks are using Prometheus directly or are using dashboards on top of Prometheus with Grafana. That's like the basic scenario that we were seeing. And there is one challenge to it, like scaling the applications, and also one part of scaling the Prometheus clusters. What I won't talk about today so much about how to scale Prometheus clusters and how to make a high availability setup of Prometheus clusters. There are other great projects out there. I'm not sure. I've not yet put it on the slides, but one of those is, for example, Thanos was also heavily featured at KubeCon. The other one I think I heard is Victoria Metrics, but you will find some of those solutions already. What I try to tackle in this presentation is how to actually scale all the configurations that you need for Grafana and Prometheus, because you're monitoring a lot of different applications. So the challenge number one that we have seen is you need a couple of those YAML files for managing Prometheus. It's scrape jobs, alerting rules. Then most often you have Grafana dashboards on top of it, where you manage also your dashboard configurations, not in YAML, but most often in JSON. So you have all these configurations, you write them, you apply them, and that's fine in the beginning. But like day 2 operations are not very safe if you just like rewrite the file, apply it, and like hope it's working in production. So there is really the problem of how all those files, they are like either on your hard drive, or they are applied in the cluster, or they are maybe versioned in some repository, but maybe they are not versioned, but maybe not kept in sync between the version the repository like GitHub and the cluster. So what we saw is one kind of promising solution to this, to follow a GitOps approach. We also saw this in the first presentation. They're also following a GitOps approach. Also Captain, that we will say later in this presentation, is following a GitOps approach. I think it has shown very, very mature, a very mature solution to these kind of problems, that you put all the files in the Git repository, it's managed in the Git repository, and then you have some kind of operator or some kind of synchronization mechanism between the Git repository and your actual Prometheus installation, your alert managers that are part of Prometheus, your Grafana. So you really put all the files into the Git repository, so you can have all the benefits of Git, like the version control, access control, branching mechanism, these kind of things. And then you have one component, let's call it an operator, matching this desired state to the actual state. So this has shown that it's a promising solution, and not to edit these files, and then you have to take care of which file is actually applied in your production environments. So with this also, you can completely reduce the effort of some manual edits in production. Even if you would do it, the operator would take care to kind of roll it back, and always the single source of truth is what's in your Git repository. So this is something that's kind of, let's call it kind of the basis that you should always do. The second problem that we saw is, or let's call it the challenge, it's a lot of files that you have to come up with. Your scrape jobs, all these configurations, your alerting rules, and all those different dashboards, either for different personas or for different projects. So you rewrite a lot of those files. And it's, as I've written here, it's not one, but it's really a lot of configuration that you have to come up with. Some configuration is different if you use the Prometheus operator than from like the traditional way how to deploy Prometheus, but still it cannot really abstract away all the details. So you always have to write a lot of different configuration files. So what we saw, and I think it's a very good idea to use them, are code generators. There are a couple of them that have already shown production usage. So I put them at the end of the slide deck. There are a couple of code generators. You feed them with your input data as you would do like always with a code generator. You define probably some kind of error budgets or SLO. Most of them are like SLO driven or SRE driven from the site reliability engineering. So you would feed them with some of your, let's say, the boundaries of acceptable metrics, and they will create all the YAML files from those from those input parameters, and can even create Grafana dashboards and these kind of things. So you basically reduce the amount of configuration files that you have to come up with. You would feed the code generators, and then you would put the files in your Git repository so that the operator can sync them to a Prometheus or a loading manager and Grafana instances. Still, there is one problem, that there are different code generators for those different kind of configuration files. And what we saw is that even if code generators are heavily used, or maybe because of them they're heavily used, sometimes the configuration, they kind of drift out of sync. So the configuration for the scrape job is a different configuration for the dashboard configuration, because they are not based on the same input files. You might have one code generator that is creating these kind of configuration files, but a very different code generator that is generating this kind of configuration files, and they might be fed by different input parameters. So that might be a problem, but I think it's a problem that you will not face at the very beginning, but you will face it eventually when you're following these kind of patterns. So what we have come up with is a solution to put as much as possible of those input parameters into SRE concept-based files. So site reliability engineering concepts. We are using a lot of those concepts in this project called Captain, and it's basically you try to abstract from implementation details, and you talk about the quality of services, the quality of microservices. And with this, you can define the quality of microservices and can define where kind of to locate the microservices, which endpoints they expose, and then you can automatically generate the scrape jobs, the alerting rules, the dashboard configurations, because all those concepts have already all the necessary information that you will need. And that's also basically defining, gives you the possibility to define what you want and not so much how you want it, because the how is already covered by code generators, by operators, by all these automations that we can put in place and that we should use, because running applications on Kubernetes is like, it's very simple if you only have like a very small Kubernetes cluster and you only run a small application consisting of like 10 microservices, but it's very, very complex in a large scale environment. And we I work at Dynatrace, as you saw in the first slide, and we have a lot of large customers that are probably switching from Prometheus to the Dynatrace solution, but they might still have Prometheus for other projects that they like. They don't want to use with our solution. That's totally fine, but they still can profit from this open source project called Captain, because it can still automate it. And we will see just in a second that building upon those SRE concepts, you're also abstracting from the actual tool implementation. So that's a very powerful method how to reuse all the configuration that you will write. So with this, I explained a bit about the most prevalent challenges that we saw when working with customers, and we kind of explained a little bit how you can overcome them. And I want to show you one potential solution in terms of an open source project. It was founded at Dynatrace, but now it's completely open source project. It's on GitHub. We have like already, we are pretty proud that we already have a couple of other companies contributing to Captain since they're using it and they like it, and they also want to contribute back to Captain. So that's pretty cool. And I want to show you a little bit how you can use Captain for automating all these configurations of Prometheus and Grafana. But actually Captain was not invented to do this, but it's in its core, it's an automate. In its core, I think I have it on the next slide. Let me just here. In its core, it's an event-based control plane for continuous delivery and automated operations. So it's not an operator, but it's an event-based control plane. So it lives in your Kubernetes cluster and lives and listens for events that are coming in via the API. And so Captain can act upon those requests from the API and can trigger then predefined workflows, or in the next version also customizable workflows for continuous delivery and automated operations. So for continuous delivery, Captain can act as a control plane for Helm, for Argo CD, for whatever other solutions that are out there, for like deployments with Ansible, for example. And Captain can control like the deployment, then triggering the testing phase, then triggering a validation phase in terms of, we call them Captain quality gates, because it's automatically checking the quality of the microservices that have just been deployed and tested. And then Captain can even trigger deployment to the next stage, like from pre-production to production. So that's the Captain control plane. It was initially built for this workflow and an automated operation workflow. So if some Prometheus alerts or Dynatrace problem tickets come in, then Captain can react on this and can either scale a deployment, roll it back, toggle some feature flags in an external solution, these kind of things. So Captain can also be used as a self-healing framework on top of your Kubernetes cluster. But as it's event-based, we can also use it for configuring our Prometheus ecosystem when we onboard new workloads to Kubernetes or to Prometheus. So how does it look like? How can we basically do all these things that I just talked about? The idea is that Captain itself, it's a couple of small microservices that live in your Kubernetes cluster, and we call it the Captain control plane. So the control plane is basically the part where you can connect your external services, and Captain will control the workflow or control the communication between the services. So Captain can be connected to a Git repository to have to fulfill the GitOps approach. Captain always runs its internal Git repository, because for some projects you might not want to link it to Bitbucket or GitLab or GitHub. So you can also use it with its internal Git repository, but you can always link it to one external Git repository. So Captain will synchronize its internal configuration, and the configuration of the services you onboard will synchronize it also to your external Git provider. It can be connected, for example, to some continuous delivery tool, like we are using Helm for the deployment. You can use Argo, you can use Jenkins. So Captain can trigger these deployments once the change in the GitOps in the Git repository has been detected. Captain can reach out to testing automation tools, to ChatOps tools, to observability tools like Prometheus, Dynatrace, or some others, and to all those, basically to all other tools that you will connect to Captain with a small service. Since Captain is event-based, so everything you have to send to Captain is a cloud event. It's also a CNCF project, and everything that's sent from Captain is also a cloud event. So that the interface between Captain and other tools is very clearly defined. Setting up Captain is easy just with the environment definition file. We call it a shipyard file. And by now you might have seen that with Captain, it's basically the pronunciation of captain of a ship. And we use some of those nautical terms like a shipyard file or some other files that we'll probably see in the next slides. So Captain is this control plane, and let's see how we can then connect our Prometheus ecosystem to this control plane and how we can automate and scale onboarding new applications to Prometheus and Bachmann. So as I said, we are basing most of the configuration in Captain on SRE best practices. First of all, we are using service level indicators. A service level indicators is really just let's say it's just a metric. Like a metric is behind the service level indicator, and we have one example here. So the error rate of a login request, that's already your service level indicator, and we will use service level objectives upon the service level indicators to define real objectives for our services, like the login rate. The login error rate, like we are reusing the service level indicator here, the login error rate must be less than 2% for the last 30 minutes, something like this. So we have our service level objective, and now we can use this objective to check the quality against this, or also to define thresholds, to define alerts. And you can go, like the SRE community goes even further and also defines service level agreements. They are more business related. So we will more focus on the first two, service level indicators and service level objectives. We also, like for observability's best practices, we see that a lot of, working with different organizations, we saw that a lot of those organizations are using red metrics, like as the 3 standard metrics, like a response time, error rate, and throughput. And so we have already put these metrics, we already included it in Captain, so you can already make use of them and you don't have to define it. So what does it mean if you have to define something? You basically come up with your service level indicator file that is just a key value pair, and the key is the name of the indicator, and the value would be the API call or the PromQL to fulfill this, to basically to get the metric to fulfill this key here. So the error rate, and you just come up with whatever PromQL might be right for you, but as said, we already defined it for the error rate, the throughput, and the response time. So, but in this example, I defined some things like the number of database calls for a specific service. So I can reuse this in my service level objective file. And in the objective file, I just use the indicator names. I don't have to use the API calls anymore. So in this sense, we can easily replace the data provider. So if you want to switch from Prometheus to Datadog or to Dynatrace or to some others, then we can easily exchange it. Or if you also, if you want to reuse the objective files, it's easy because in the objective file, we don't have any names of the actual service. So we use placeholders and variables here, so we can easily reuse them for different services. So what do we define here? It's really the objective. It's by kind of a criteria that our SLI has to fulfill. Like we are basing it on the service level indicator, the error rate, and it's only allowed to pass if it only has one criteria for the pass criteria. And it's only allowed to pass if the error rate is smaller or equal to 1%. So not a lot of errors are allowed for this microservice that we are using this service level objective file for. And we can make like a large or not so large, whatever we want, SLO file containing different objectives basing on different SLIs. We can combine criterias, we can have PaaS criterias and warning criterias. So every time we are not meeting PaaS criterias, we'll check for the warning criteria. And if we check, if we can make it into the warning criteria, then we'll get like half the points. And in total, we can check if the total score is fine. And this makes up a Captain quality gate. But we can also use this file to configure our monitoring solutions and to configure our dashboards. So we just use the Captain CLI to configure our monitoring tool. So it would be Captain configure monitoring Prometheus. This will be received by the Captain control plane. And then we have different service connectors to Grafana, Prometheus, Dynatrace, whatever tool you want to connect. And they will interpret it in the way that they will send out the specific API calls to these tools. So all those tools that are interested in the monitoring configuration for Prometheus, they will receive this event. They will use this event to interpret it in a way to send out the API calls to Grafana to configure Grafana dashboards, or to Prometheus to set up the Prometheus scrape jobs and alerting rules and recording rules and these kind of things. So with this, we can really make sure that everything is based on one input file, and the rest is done by all this. Excuse me. I have to take a sip of water. By all those connectors that are attached to Captain, to the Captain control plane, and they will reach out, or they will do the tool-specific interpretations. We can also reuse the same file, so I didn't change the file on the left-hand side, but I just want to show you how it works in the use case of a deployment. So we might already have set up the Captain, or Captain has already distributed all the events to set up your Prometheus, scrape jobs, and the Grafana dashboards. And now during the deployment, or just because the developer needs to know the quality of the service, we can trigger the Captain quality gates. So we can either have it done during the Captain workflow, when Captain does the deployment, triggers the test, and then does the evaluation, or we can trigger it with the Captain CLI to start an evaluation for like 30 minutes for one specific microservices based on those two files. So actually, there is no need to also use these two files here in the CLI, because they are already stored in the GitOps, in the Git repository, but just for like giving you the idea how it works. So it's based on the SLIs and SLO files. So first, Captain will query all the SLIs from the different providers like Prometheus, Neoload, or other tools. We'll integrate this, or we'll fetch the SLIs. So we will fetch the error rate, the number of database calls, the response time. Then Captain will check the quality, will evaluate it, and will score it. So Captain will take a look at the SLO file, will score each service level objective, will assign it a score, and then come up with a total score. And the total score can either be passing or failing, or in between. Then you will get a warning. If it's like not enough to pass, you would receive a warning. So with this, you can have a mature approach to have quality gates and quality checks whenever you traverse from one stage like pre-production to another stage like production, or from development to staging. And you can reuse those files. You can make them more restrictive, you can make them more relaxed, all this criteria. You can base it on previous runs, like only an increase of 2% to the previous runs is allowed. You can use fixed thresholds like we use here. So it's a very easy way to use it for both the checks for the quality gates during the deployments, but also for setting up all the solutions for monitoring and dashboarding, because those files contain all the information that you usually need. Yeah, so that was just the end of the example here. So how does it feel like, or how does it work to use Captain? I have to take a look at the clock, but I think I still have like a couple of minutes left. So it's, as said, it's event-based, and it uses a Git repository to store all the configuration. And for setting up a project in Captain, and for project, we can think of like an application. So like your web shop would be the project, and then you have a login service, a shopping cart service, a checkout service. All the services would be part of the project. And we'll set up the project based on the shipyard file, where you basically define only your stages. Like we have staging, we have production, and then we define which kind of deployment strategies, which kind of test strategies we want to execute. So here we don't define any tooling that's defined in the Captain's uniform. So we can also easily exchange the tooling. But we will just describe how our project looks like. And Captain will make sure to set up the Git repository, to set up Istio in the correct way. We are using Istio for blue-green deployments, but you don't have to care about it because we are using it behind the scenes. We are using, we can use Helm or Argo CD for deployments. We have baked-in services that can use JMeter or Neoload. We have, I think we already have the first contribution started to also include BlazeMeter as a different testing tool to be triggered. So all these tools, they can be connected by defining them in the Captain's uniform. So the next part would be to onboard services, because we already onboarded now, or we already created the project. So next step is to onboard services to our project. So we onboard a service like carts, a shopping cart service. And for onboarding, we really need, as the only thing, a help chart, because the help chart defines like this, how the small application should be deployed. So Captain takes this help chart, puts it into its internal repository, and will take care of it. So Captain will put it there. We can use then the help chart and the SLI and SLO files that you also put in the Git repository to configure the monitoring solution. So we also use the Captain CLI to do Captain configure monitor Prometheus. Captain will configure those solutions by setting up all those files. And then we can use Captain to deploy our artifacts. We're calling artifacts. So everything, like each microservice is its own artifact in Captain. So you would use the Captain CLI to send an event about a new artifact. You can describe it with parameters. In this case, we defined the new version of a shopping cart image. So it can be from Quay or Docker Hub. And Captain will make sure to deploy it. First, to rewrite the Git internal repository or on GitHub, to rewrite it, then to trigger the deployment tool, like in this case, it's Helm, to do a blue-green deployment. So we put all the new images or the new pods next to the previous ones. Captain will trigger the tests. As we saw in the shipyard file earlier, it's configured as performance tests. So we are executing performance tests with JMeter. Captain will then automatically do the scoring. And based on the scoring, we'll decide to promote it to the next stage or to roll it back to the previous version. So in this case, it's good to go. We can promote it. We can send all these events along the way to Slack, but maybe we just want to know about all the promotions or rollbacks. So we send this, and Captain will start the same workflow also in the next stage. So in our next stage is production. So it will be the same workflow. We haven't defined any performance tests or any tests at all. So this will be just skipped this phase. Captain can still do a performance evaluation for like the last 5 minutes. As we saw in production, it's not that common to do some performance testing in production. So it's basically our end users are doing this performance evaluation for us or performance testing, and we just want to evaluate. Like we put it in production and then we check like half an hour later, we check again the quality of the new version of the microservice, if it's good, or if we see some quality decreases to the previous version, then we want to roll it back automatically. So we don't have to watch it actively, but everything's done by the tool. And then we can keep it, or we can roll it back to the previous version. So that's basically how you can use Captain for continuous delivery. I have not shown the automated operations part, but it's again basis on YAML files where you just define if there's some problem pattern coming in, what are all the actions that Captain should trigger to remediate the issue. And between all the steps that Captain is executing, every time there is a quality check with the Captain quality gates. So this is the automated operations workflow of Captain. I've only showed you like how you can use Captain to automatically configure Prometheus and Grafana, and how to do deployments with Captain. For the Prometheus configuration, we have basically 3 different services that are responsible for it. The first one is the Prometheus service that is really for configuring Prometheus and receiving alerts from the Prometheus Alert Manager and then translating them into cloud events so that Captain can understand them. Then we have the Prometheus SLI service where you can have Captain reach out to the SLI service, and the SLI service reaches out to Prometheus to collect all the different metrics, puts it in a format that Captain can understand it. And then we have the Grafana service that is basically creating all these dashboards based on the configuration of Captain. So I put all the links that I went through. I also put them in here. So again, the blog here, the code generators I was mentioning before, and not my presentation, but a very nice presentation about the RED method, how you can use all these metrics in your monitoring solutions. And yeah, with that, if you think Captain is something that you would be interested, I'm not so much familiar with Project Syn that we heard at the beginning. I think there might be some similarities, although I think Project Syn is more for multi-cluster and not so much multi-stage deployments. But check it out. Take a look at Project Syn. Also take a look at Captain. It's captain.sh. If you want to take a look at the source code, everything's available on GitHub. It's captain/captain. That's our main repository. Yeah, with that, thanks so much. If you have any questions, please put them in the Q&A section. I think there's already something. I cannot open it.
Exactly.
Okay, cool.
If you want, Jürgen, you can answer that directly.
Yes, let me take a look at the question. How does Captain differ to relate to existing CI/CD tools like GitLab, Argo, etc.? There seems to be quite some overlap with those tools. Yes, so very good question. First of all, so Captain does not, let's say, replace those tools, but Captain is more using those tools. So as said, we are using Argo CD for deployments. We can also use Helm for deployments. But so Captain will trigger Argo CD for the deployment. But let's take a look here, probably here, this slide. So like Captain would rewrite the Helm chart, or like, yeah, basically the Helm chart, then trigger Argo CD for the deployments, like to do blue-green deployments with Argo CD, or with Argo rollouts to do canary releases. But Argo is not automatically triggering all those tests and then doing evaluations. So we are using Argo CD, and we are more the control plane on top of it. So when Argo CD has done the deployments, we are then triggering the testing tools that you will connect to Captain. So like Neoload or JMeter or BlazeMeter, then Captain will execute or start the tests by sending the events to the testing tools. Please go ahead, start the tests. When the tests are finished, those testing tools, they just send back one event to Captain that those tests have been finished, and Captain knows exactly the time frame of these tools, which service was tested, and then can go ahead and do the scoring of the quality. So we are using those existing CI/CD tools in the whole workflow. We are reusing them because they are already very mature. So I think rewriting a complete CD tool or a CI tool from scratch might be very, very difficult to compete with other solutions, but we are reusing what's already there. Yes, there is a follow-up question with GitLab. Yes, so we can also trigger, and we are using GitLab. I just want to show you something, Captain, I think in the Captain sandbox. Let me just jump into one of those services, because we have some folks that are using GitLab. And let me, if I find it, yes. So we have one service in the Captain sandbox, all external contributions from external partners, if they want to give it back to the Captain community, we first put it in the Captain sandbox. So the Captain sandbox is basically, this repository holds a lot of external contributions. And Christian Heckelmann from Germany, he was, or he is developing the GitLab service. And if you want to take a look what it's really doing, he was very kind to also take part of one of those Captain community meetings. And I think there's some, yeah, here we go. So we also see it here. So they were talking about how to, how they are using Captain with GitLab, and also Christian here, he was explaining how they are using it with GitLab Captain, using GitLab pipelines, but being a control plane on top of those pipelines. So I think I could just answer live. So I will put those links in the chat if you want to take a look. I think I should mark it here. So. Are there any more questions?
I think we're good.
Okay, so then thanks a lot. I'll stop my sharing and I will go ahead and put all those links in the chat. Thanks for the questions, really great questions.
Perfect. Thank you very much, Jürgen. That was really interesting. And then I'd say we continue with Roman. Thank you very much. Have fun, enjoy.
Yes, thank you very much. Quick sound, screen, audio test.
Perfect.
All good. Good. Then I'll minimize this one. And then let's get started. I'm excited to talk about cloud native build packs today. And I hope I can show you what they are, how they work, and why I would recommend you to have a closer look at it and consider their usage. If I say I mean, of course, myself. My name is Roman. I'm working at Swisscom. I've joined the company 8 years ago. I gained various experience in roles as a network, as a software, and as a DevOps engineer. My current occupation is as a cloud solutions architect, where I help our customers to make the most of our cloud offerings. Now, I can't have a talk about cloud native build packs without mentioning Buildpacks, and I can't talk about Buildpacks without mentioning Cloud Foundry. So I would start with that right afterwards. Then there are a couple of advantages and disadvantages of Buildpacks, to which I will then shift to the introduction of cloud native build packs. And of course, there will be a demo, and afterwards a conclusion and outlook. So let's start with the DevOps life cycle, if you want to say so. You know the issue here. We have, or you have code, you want to build that, you want to test it, release it, and deploy it. So in a Java environment, you would say you have your war or your jar archive, and now you want to deploy that. You can use, for example, Ansible to copy it via SSH to your server, your application server. You can use Docker images, or you could use CF push. And CF push is the method you would choose for if you're a Cloud Foundry developer. And in that sense, a quick recap what Cloud Foundry is. I believe most of the people in the audience know what Cloud Foundry is, so I want just quickly give an overview of the milestones in the recent years. So the project was officially announced already 9 years ago. Noteworthy, I would say, is the Docker support that was introduced 2015. And then there was this open service broker API initiative that was backed by large companies like Google, IBM, VMware, and of course, to mention Red Hat, to please Simon in this call. And afterwards, the main things were the support for Kubernetes. So in the last recent years, we saw the adoption of Cloud Foundry, the developments to get the platform up and running on top of Kubernetes, so the platform itself, but also to allow the users to run their workload on Kubernetes itself. So these are the highlights of the last 2-3 years, and the journey simply continues in that way. Cloud Foundry, they send out user surveys every year, and from the last user survey, it's quite obvious here that the people from all roles, developers, operators, and from business representatives say the vast majority of they say they save time and money with Cloud Foundry. And there is also a famous quote. They say what once was an app a year company is nowadays an app a week company. And this is something I can really stand behind from my experience in a former DevOps team at Swisscom, where we were responsible for a huge monolithic application. We split that up into multiple microservices. And back then in 2016, when Swisscom decided to launch its internal Cloud Foundry offering, we got onboarded to that as well. And so the journey there was quite straightforward. And looking back, Swisscom used to have 4 large cluster releases a year. So every team, every application had to align with a schedule to deploy their applications only 4 times a year. And now with the help of Cloud Foundry, the teams got to be a little bit more autonomous. They could deploy and release whenever they wanted, I would say. In my former team, that was the case. So you could say the first release in a week was on Monday morning before 9 o'clock. And now the question is, how does Cloud Foundry do this? I showed you the cf push command. And if you issue that with your artifact, for example, the Java jar file, you upload it to Cloud Foundry with cf push, and then the bits, as soon as they are in the platform, they are called package. And then Cloud Foundry checks which build packs are suitable to run this sort of application. So quite briefly, a build pack is something or a piece of technology that helps you run your application. It's specific to some middleware or application runtime like Java or Go or PHP, Node.js, whatever you like. And these are built then on top, or they use a stack that is then just a file system beneath it, for example, based on Ubuntu 18.04. So the staging process in essentially is simply check which build path is capable of running your package. And if this is clear and defined, it will result in a droplet. Then it's time for the configuration and the environment variables. As soon as they are in place and you start your droplet, it creates one or multiple processes. So it's quite obvious build packs have some advantages. For example, as an application developer, you don't need to take care of the JRE in a Java world. You get a patched up-to-date JRE. Also for Java, there is a plugin or something in the Java build pack, the memory calculator that takes care of the heap configuration or the memory calculation of your application. And for example, in the Nginx build pack, you don't need to provide the binaries for Nginx. You just upload the Nginx config and Cloud Foundry will simply make it run. Then I like Docker, but I think personally writing Docker files doesn't spark too much joy. So I simply can push my application and Cloud Foundry will take care of it. Now there are a couple of downsides as well, or challenges. For example, if you push your application to Cloud Foundry, you get this droplet and you don't really download the droplet afterwards. So in a sense, if you develop locally, that piece of application might differ slightly from what you've pushed or what is running in Cloud Foundry. Then there are different stages. Let's say you push your application once to a test environment and once to a production environment. Then this is essentially resulting in two different droplets. That means the odds are quite low, but it could be that between two pushes, something changed in the build pack. So you don't have this parity as we strive for using the 12 factors approaches. Then for security, it's a little bit harder to scan for vulnerabilities. I couldn't find a scanner scanning Cloud Foundry droplets. It would be much easier to simply scan Docker images. And what I've already mentioned with the stages, breaking changes in the build packs might break your deployment, and then it might be already too late. So you might notice it too late. And all these things are then addressed with Cloud Native Build Packs. So Cloud Native Build Packs is a CNCF sandbox project, and it offers you as an interface mainly a CLI tool called Pack. And Pack gives you certain commands. For example, you can use Pack build or Pack inspect image, inspect builder, and suggest builders. These are I would say the 4 most common commands for Pack. So with build, you simply generate your application image, the Docker image from your application code. And with builders, these are used to determine which build packs are really taken into consideration. To show you how it works, you use pack build, and all the possible build packs that are supported by the builder are then applied to your source code. Quite noteworthy is the fact that they create a layered Docker image. So if you develop your application and you simply change one line of code, you don't need to rebuild the whole Docker image. Simply the topmost layer, the application layer. In a Java world, you wouldn't change your dependencies just with one line of code, most likely. That is good for caching, of course, and for performance, as we see in a minute. And also noteworthy is that now this doesn't have to be deployed to Cloud Foundry anymore, because you've got this standardized Docker image, and you can deploy that to whichever cloud platform you'd like. I have a demo with prepared to deploy to Cloud Foundry, but also to a Kubernetes cluster. And with that, we already arrived at the demo here. What I want to show you is a really simple application. It is published on GitHub. You'll find the links afterwards in the presentation. A simple Java application that polls the current weather conditions from a certain location, wherever you want, and push that to a backend. And this backend then stores the conditions in an Elasticsearch DB, where I wrote or created a Kibana dashboard to display it. And obviously, the application needs to have credentials to access the Open Weather API. That is then based on the platform in Cloud Foundry. It's a secret store, or in Kubernetes simply secrets then. So in Kibana, the dashboard should then look like this. I have a couple of applications already deployed on different occasions. So I currently have 4 locations in Switzerland that I'm tracking the weather conditions currently. We see it on a map. We have Lausanne, Lucerne, I believe that's Rapperswil, and Basel. Now I think it will make sense to have 2 more locations, for example, Biel and Zug. Let's try to get the weather conditions for these 2 locations. So what I am doing, I have checked out the Git repository. All files are there locally. And what I'm now going to do is I want to create that cloud native image or the Docker image with the cloud native Buildpacks support. Now, because this is a Spring Boot application and the Spring developers luckily support that pack initiative as a first-class citizen, they included the pack CLI in the Gradle tasks. So I simply need to invoke a Gradle task to build my Spring Boot application, and the result will then be a Docker image that was introduced with the latest minor version, Spring Boot 2.3. And then what the command does is it pulls a builder image and a run image. The builder image is used to, as the name says, to build the image. For example, you would need to have a JDK present in the image, but afterwards, for running the image, you would need to have a JRE. And this is here labeled or stated what is taking place here during the build process. We have various build packs now participating in this build process. For example, the JRE exactly in version 11, Java 11. And then if everything went through successfully, I received the confirmation that my Docker image was built successfully within 19 seconds. Now, this was that fast because it was cached, the build and the run image already. So it didn't have to be downloaded from Docker Hub. Now, what I do, I quickly get the tag for future reference afterwards, and I push the image to Docker Hub. Now, this might take some time, so I open up a new tab here, get the tag again, and let's see how the image looks like. As you see, the image is around 260 megabytes large in file size. That's good. We'll come to that afterwards. I've seen in a previous version of Pack or a different used builder image or a run image that took over 1 gigabyte of disk space. So it's good to see that they are optimizing on this one as well. Then Pack also supports now to inspect the image later on. This is the same output as we've seen during the build process. We see which images were used, which versions of the build packs were used, and all that stuff around it. Now, I hope in the meantime, yes, the image was pushed to Docker Hub. And what I do now is to check out my Cloud Foundry manifest with the definition of which image I want to push to Cloud Foundry, and the configuration now tells me, or the environment variable I can set to target the location I'd like to monitor. So with that set, the application is ready to be pushed to Cloud Foundry. I do that with the cf push command, and this now should take some seconds to spin it up and get it running. The good thing is it's a little bit faster than the build pack approach because the Docker image is already there and Cloud Foundry just needs to start it. So that is the case. I quickly check the logs. and we see that the last entry here, the weather data was queried for Beal and was received and then pushed to the backend service. So let's do the same with our Kubernetes deployment. I have this deployment prepared here. I enter now what we say Zug as my location. The tag was updated here. I have the API credentials there in a secret, so I need to simply apply that. I start with it with kubectl apply this file. That's configured. I use kube control apply for the deployment, and whoops, and let's see the outcome with kubectl get pods. And I hope I have now covered all possible pronunciations of kubectl to please the audience. We see it's already running. Let's give it a couple of seconds till it's really ready. This seems to be the case now. I get the pod, and let's check the logs of the pod as well. Also here, the application got the weather conditions and pushed them to the backend. And now if everything worked as intended, I should be able to refresh it here, and I get 2 more bubbles on the map, one for Beal and one for Zug. Now, I'm not the best Kibana artist here, so there's simply a horizontal line from the beginning to the last data point, but we see it here in the log that the last pushes included the locations for these towns as well. That's already it for the demo. I switch back to the presentation, and I would say we get to the outlook. What I've already seen in the demo, the second point here, I assume the Cloud Native Buildpack project will also invest some time in optimizing these Buildpacks to make them as small as possible. Possibly give you the option to add or remove certain CLIs. Maybe you are interested in having curl within your Docker container. I don't know. Then, of course, there will be more Buildpacks to support your technology. However, already most of the technologies are already supported. If you check out the website, Java, Go, Node.js, whatever you'd like, I think already most of them are supported right now. Now, you might ask, you're a Cloud Foundry developer and you quite like what Cloud Foundry is doing for you. You simply push the application code and Cloud Foundry takes care of the rest. You don't need to use Cloud Native Buildpacks, but in the future, if you have a look at Cloud Foundry on Kubernetes, that's a project to have everything on top of Kubernetes running. There's this tool or this add-on called KPack that will then take care of what this Cloud Foundry is doing today to accept your application code and create the Cloud Native Buildpacks out of that application code. And with that, we're already at the conclusion. I think it's a very, very interesting project, and I hope I could show you how simply it is to use. It's really nice. It supports now local development with the Docker images. You have reproducible builds. You can scan the build packs or the resulting Docker images for vulnerabilities. A personal pro is I don't need to maintain Docker files in the future, and you can deploy and run it anywhere. Given the demo covered Swisscom platforms like Cloud Foundry and our Kubernetes offering, you could also run it on any global public provider. Yes, these were the main advantages. I hope I could show you that, and I hope you will give it a try as well. And with that, I would like to end this presentation. Of course, I'm from Swisscom, and I can't stop or resist me from announcing what we have to offer from a Swisscom perspective. We have various cloud offerings as well, given or say Kubernetes or OpenShift or Cloud Foundry, whatever you like. There are a couple of links I have within the presentation. If the session is recorded, you can hit pause and replay it. Otherwise, hopefully you can then download the presentation afterwards and click on the links for further reading. And with that, I say thank you very much for your attention. And if there are any questions, I am more than willing to answer them. Thank you.
Thank you very much, Roman. So I would say let's do a really quick Q&A if someone has any questions. Otherwise, let me again thank you all speakers for the nice talks. Very interesting today, as always. And yeah, I don't see any questions, any hot topics or discussions going on. So I would say let's yeah, stop it here. And thanks everyone. Have a great evening and see you on the next Cloud Native Computing Meetup.
Thank you so much.
Thanks, everyone.
Thanks, guys.
Bye-bye.
Bye. Thanks.
Have a great day. Thank you. Bye-bye. Bye-bye.